All right. It's not a continuous function. It's just not a single value triangle, so this is not good for the geometric property. And also, it is not a continuous function. It also cannot be used as a geometric property, right? And the third one should be a linear function. So if it is not linear, so the graph is just like this kind of graph. It's continuous but single value, but not linear. So it is very difficult you to get a relationship, linear relationship, make a linear relationship with x and theta. That's also very difficult to make or calibrate the thermometer. Nowadays, there are many digitally we can calibrate those, and this kind of graph also has a thermometric properties, right? But it's not a good, right? So this is, you can say, that's not a linear function. So these kind of functions we cannot use as a thermometric property. And say that's a correct one, then we draw the graph. I'm drawing here. It should be linear, so the single value and continuous. So we can draw the graph like this. A graph like this. So this is the thermometric property. We can see thermometric property, and this is the temperature, right? Arrow with it, so just any temperature value you can use. And also this may be increasing and or decreasing, and you can use, right? So it may be a graph like this also. Decreasing because with the temperature, thermometric can be changed, decreases, right? And using this kind of, this is a linear function, continuous and single value. So then this is just like a y equals mx plus c type graph. So you can write this the thermometric property that's equals to the that's constant times theta plus the constant, right? So this is a gradient, this intercept, and here it is intercept, right? So we remember that last week we discussed that the two fixed values, fixed temperatures. Fixed point, one is for the lower fixed point and other one is for the upper fixed point. Use these fixed points, we can describe the thermometric equation. That the equation we can use to get any temperature from the particular thermometers. We can introduce a function then. But that's at the lower fixed point. Let's see here the lower fixed point theta L lower fixed point. The thermometric property, the value of the thermometric property I will take as XL. Right. At the upper fixed point, in different temperature, this value is different, right? No. This upper fixed point or higher fixed point like the H. So the thermometric property, the value of the thermometric property corresponding to that is XL, XH, sorry. So at any other given any temperature, because it has theta. So let's see it is corresponding thermometric property x theta. Okay. Using this equation and also using I can say what should do here. I'll substitute the values there, right? That's at the lower fixed point. That's it. You can write XL equals to the A times theta L plus P. That's the one equation you can and then high fixed point that theta A theta H plus B, the second. Right. So you can subtract the first one by second. Right. Second. So then you can write that XH minus XL, that's equals to the, here B be cancelled. So then it is A times theta L minus H minus A. So then A you can find. That's why this should be the linear condition. If it is a linear function, only you can get this A easily. See that, right? So using this also you can calculate B, value of B also. B you can write as, from this equation 1, let's say it is XL minus A theta. And value of A you can subtract. Yeah. So I will find it, right? So this value of B, so that that's simplify and get the value. We can take it directly like this. Low fixed point and theta. Oh yes, we can calculate. So that is XL minus X minus XL or theta H minus theta L and theta X, right? So simplify करना, make a simplify करना, just so you can get a value for B. I will directly write here, right? Right here, actually, this general formula you can write as X theta, right? Theta, then this X theta equals A theta plus B. So this also you can write as a one, because we need to combine this with this theta, because we need to find the theta, the temperature at any temperature. We need to what is the thermometric property is given. So if you know the thermometric property, then you have be able to get the temperature corresponding to that, right? So then it's easy way to combine. Let's use this value also. So I will simplify this in different way then, right? To find B. So then it's easy. By simplifying this, you can get the B like this also. And but combining these three equations, we can get the, let's say this is a gradient of this graph. Let's say an alpha. If you write the equation for an alpha, also you can get this. So how you get it? Here, write the gradients. Gradient you can write in from the upper one. This difference divided by this difference. So this XH minus XL divided by theta H minus theta L. It's also equals to, from this triangle also you can get X theta minus XL divided by theta minus theta L. And using this also you can get the this theta value make the equation in the multiple in x theta xh minus xl divided by theta h minus theta l. This is theta minus xl by theta minus theta l. So then you can write this theta, that's theta l minus, sorry, theta minus theta l, theta minus theta l, we got this side, and then it's equals to the x theta minus xl divided by xh minus xl times theta h minus theta l. So the theta unknown temperature you want, then x theta minus xl divided by here theta, sorry, xh minus xl times theta h minus theta l plus theta. So this is the equation you got, right? By using this equation, actually you can find any unknown temperature. If you know the thermometric properties corresponding to the other temperature, that is for the lower fixed point, upper fixed point, and the unknown temperature theta. Can happy then theta temperature, if you know these values, theta L and theta x theta xl xh values, can low fixed point thermometric property, upper fixed point thermometric property unknown temperature reading to obtain. And then by using this equation, you can find any unknown temperature. Use this equation, that thermometric property should have the linear continuous and single value function with the temperature. If not, you cannot use this equation. That's why that's the condition given, right? I think you got this equation and it's not. You got one. Now, for a different thermometric scale, the temperature scales, we can use this equation different. That's Celsius, Kelvin, and Fahrenheit. We can use this. The different thermometer scales, they are per point, and that's the fixed points are different. Okay. This is called as a thermometric equation. That's a thermometer equation. Any thermometer. Let's as example, let's see here. If you know the value of at low fixed point is, we know that is 0 Celsius per Celsius. Upper fixed point is 100 Celsius, right? Any temperature theta. Let's say the thermometric property given by this mercury thermometer. Let's say the length is 2 centimeters. Let's say the 70 centimeters. Upper fixed point, that's the length of the mercury column. And if you given any unknown temperature, that height or length is given at 8 centimeters, then you can use this equation to find the unknown temperature. As I mentioned there, that is x is 8 minus 2. This temperature given, right? Divided by this 17 minus 2. It's multiplied by, that's the difference is 100 plus the initial value is 0. And then this gives 6 divided by 15 multiplied by 100, right? So 66.67 like this. Directly you can calculate like this. Any unknown temperature, then you can find. Okay. Now, using this equation, we can define the different temperature scales. And there are 3 scales. One is Celsius scale. Celsius scale, the lower fixed point is 0. The upper fixed point is 100. This thing you need to remember. Lower fixed point is 0 Celsius. We consider upper fixed point, it's considered as 100 Celsius. And in between this lower and upper fixed point, we divided into 100 equal divisions. So the 1 Celsius means that's one part there, right? So then by substituting those values here, you can calculate the temperature theta is Cm used as Celsius in Celsius. That's equals to the that's a x theta value because any thermometric properties are not changed. So this ratio is constant because the same graph is right. So that is XL by XH minus XL. Thermometric properties are not changed to the scale. And this difference between these two is 100. So this is in Celsius, right? And this is the equation for the Celsius scale. So the Celsius scale is defined like this. In between the upper and lower fixed point divided into 100, right? And the lower fixed point is taken as 0. So then the scale we can consider as a Celsius scale. And then second, we consider as a Kelvin, over there we can consider it as a absolute temperature or thermometer scale. In a scale. It's also much similar to this Celsius, but the difference is this lowest. The lower fixed point is taken as 273.1 Kelvin. For fixed point, so higher fixed point is taken as 373.15 Kelvin. Right, this is called this 0 Celsius. Because this scale is defined with the kinetic energy of the molecules. The molecular kinetic energy becomes 0 at the absolute 0. So outside given is we taken this value as a Celsius 0. 0 Celsius that having a kinetic energy. Then we can substitute this value, and also in between these two you can see the difference between these two is 100. So it's also divided into 100, and so then this is not starting from 0. There's 1 Kelvin equals to the one part of this scale. So then theta in Kelvin, you can substitute the values there. This x theta minus xl part will not be changed with the scale because this is the thermometric properties are same for any scales. X theta minus xl divided by xh minus xl multiplied by the difference between these two or the 100, and also addition. They are having the lower fixed point, the theta L is not 0 here, that is 273.15 plus in Kelvin. So this is the equation corresponding to the Kelvin scale. So temperature in Kelvin scale, you can obtain using this formula. Is it clear? And the third one is for the Fahrenheit scale. If you want to let me know, then I can go to the previous page also. And the Fahrenheit scale, the lower fixed point is taken as 32 Fahrenheit degrees, and upper fixed point is taken as 212 Fahrenheit degrees. In between these two, there are 180 divisions divided. So one division is considered as a 1 Fahrenheit degree. Right. So then by substituting the other theta in Fahrenheit, you can write as the thermometric property. Points corresponding to the fixed point and multiplied by the difference between these 180 plus the low fixed point is 30. So that is in Fahrenheit. Okay, so this is the equation used for Fahrenheit scale. By using these three, then you can get the relationship between those thermometer. That's the thermometric scales, right? These scales are a relationship with Ganadura. So how you can get, because this ratio is same for this all the cases. Previous cases also you can write. This ratio you can write, this is the theta C divided by 100. In here, this ratio is equal to it's minus 273.15 divided by 100. And in Fahrenheit one, you can say, okay, I will write there. So using three scales, it's x theta over xl divided by xh minus xl should be a constant. It should be changed. So we can write in Celsius scale is the theta C divided by 100, and in Kelvin scale is theta in Kelvin divided minus 273.15 divided by 100, and other one is that is in here it is equals to the theta in Fahrenheit minus 32 degrees divided by 180. So using this, you can get the relationship between the, by using this one, let's say the first one, and the relation between these two, get the second one, Celsius and Kelvin, and using this, and you can use as the third one to get the relationship between the first one, then give the first relation, that is the theta C over 100 divided equals to the theta K minus 273.15 divided by 100. It's 100 cancel. So then you can say theta in Celsius, which equals to the theta in Kelvin minus 273.15. So it gives you that in any Kelvin temperature, that's equals to the Celsius temperature plus 273.15. Over the antamandana, we get Celsius Kelvin another relationship figure. You can get using this. Right? That's the relationship between Kelvin and Celsius. And using the second one, I'll cover this part. And using second equation, you can get the second equation is this one, and theta K minus 273.5 divided by 100 is equals to the theta F minus 32 divided by 180. So you can write it as 100 divided by 180. Then you can simplify and then you can get this in Kelvin, that's equals to the Fahrenheit scale, that's minus 32. This is 5 over 9 plus 273.15. It's the relationship between the Fahrenheit and Kelvin. And thirdly, you can say that the third equation is given, theta C equals to the Fahrenheit temperature minus 32. That's 100 divided by 80, that's 5 over 9. So if you want to get that Fahrenheit temperature is equals to the 9 by 5 theta C plus 32. So the conversion from Celsius to Fahrenheit, you can use this equation. Okay, these are the three thermometer scales and their relations between, right? Is the relationship between the Celsius, Kelvin, and the Fahrenheit. This is a relationship between Celsius and Fahrenheit. Is it okay? Is it clear for you? Then I will be the question and I'm going to okay. Okay, write this question and yeah, so then finally the temperature gives both Fahrenheit and Celsius value is equal. Right? Temperature which gives the same value for Fahrenheit and Celsius. Fahrenheit Celsius equal है ना value equal value एक आते हैं temperature का मुकाबले temperature which gives the same value for Fahrenheit and Celsius. This is the scale one. Then Fahrenheit scales. This is the first one. Second question you can write. What is the value to following? In Fahrenheit. So the first one I will do 40 Celsius. And then I will do 40 Celsius. Difference of okay, to these two questions. Single, this you can give the value. බලමු. මෙතන කොහොමද ගන්න? You can get Celsius and Fahrenheit they ask, right? So that's Fahrenheit. So and CK equals to be 509 Celsius plus 32. This should be two values to be equal, same value they given, right? So let's say theta. Some value we get them they need to read. Make a simplify color make a medical. Theta minus 9/5 theta, that's equals to the 32. Here it is minus 4 theta over 5, 32. 4 theta equals then minus 40. So minus 40 Fahrenheit and minus 4 Celsius are equals. You can come with it. Value minus 40 Celsius and minus 40 Fahrenheit. The case they came 40 year value became minus 40 here. Okay, then easily you can get from this equation. That's in Fahrenheit they're asking. 5 into 40 plus 32. There is 8 into 72 and plus 32. That is 104. It's 104. අපේ 100 ගානට උණ කියන්නේ උණ මයින්නේ ෆැරන්හයිට්. 104 විතර උණ කියලා කියන්නේ සෙල්සියස් අංශක 40ක් විතර. සාමාන්‍ය බොඩි ටෙම්පරේචර් 36 37 විතර තියෙනවා. සෙල්සියස් 3-4ක් වැඩි වෙනවා කියන්නේ it's dangerous. සෙල්සියස් එකක් වැඩි වුණා සයිල් ඩැමේජ් වෙනවා. Heat F, that's 40 Celsius different they are asking now, right? So you can see that's a 1 Celsius difference, right? 1 Celsius difference. That's equals in Fahrenheit because Celsius is divided into 0 to 100 divisions. But in Fahrenheit, the same rate is divided into 180 divisions. The 1 Celsius difference in equals Celsius difference is equals to the 1.8 Fahrenheit difference. So then you can find is how much is for 40 Celsius difference. 1 is for 1.8, then how much is for 40? So that is 72 Fahrenheit difference. 40 Celsius difference is equals to the 22 Fahrenheit difference. It's clear? හරි නේද? කාට මොනවා හරි කී ප්‍රශ්න තියෙනවා නම් කියන්න මම ආයෙත් කියන්න. No questions. Right. හරි. එහෙනම් අපි then that's another fixed point we have described here, related to this community scale. That's called a triple point. Right? That's another temperature scale we can describe with triple point. The triple point of water, right? Triple point of water. This means the pure water, ice, and water vapor. This all three phases are in equilibrium together at one temperature. That is called the triple point. So value of that is 0.01 Celsius. That means 273.16 Kelvin. Right. Triple point of body means that's a triple point. Straight and we see three phases of water means ice, water, and vapor are coexisting equilibrium. Triple cell කියලා එකක් තියෙනවා. ඒකෙන් අපි සාමාන්‍ය දන්නවනේ ඔයගොල්ලෝ දැන් අයිස් කැටයක් මේ චක්කුඩ ගෑස් කියලා බලන්න අයිස් එකේ දී වෙනවා. water there ice solids form එකක් තියෙනවා. ඊට අමතරව ඒක උඩ පොඩි vapor එකක් යනවා බලන්න පිළිගන්න. ඒ කියන්නේ සාමාන්‍ය 0.01 celsius වලදී කියන්නේ 0 එක තමයි ice තියෙන්නේ. 0.01 වෙච්ච ගමන් ඒක vapor වෙනවා liquid වෙනවා solid state එකේ තියෙනවා. So that temperature we call that is a triple. That value we can use to describe the thermometer temperature scale because it is a unique. What a unique temperature විතරයි. And also it can be changed with the pressure. Right? 0.0 that normally you predict color this 4 millimeter mercury millimeter temperature තමයි 0.1 වෙනවා කියලා. නැත්නම් ඊට වඩා වෙනස් වෙන්න පුළුවන්. You can say that's at the triple point. Temperature the T can TR here use करना. So that's equals to 0.01 Celsius degree. Also it's equals to 100. So 3.16 Kelvin. So this is at this temperature, the pressure also we can write as 4 millimeter mercury. By using this triple point, so this absolute scaling, the pressure and the temperature, we'll discuss this graph later also. And this temperature, when you reduce the Kelvin, then you can the graph like this. It's a straight line. And if you draw this graph with Celsius scale, over here, when I this is set at minus 273.5. You will see temperature corresponding to. If you draw this graph, because this is starting from 0 here in Kelvin 1, the 0.01 is, let's say, somewhere here, that is the triple point. So this pressure between this 4 millimeter of mercury, there is a pressure corresponding to the triple point. So now linear graph එකක් ඕකෙන් පුළුවන් define කරන්න thermometer එකට එන value එක කියන්නේ value එක ගන්න unknown temperature. If you know the thermometer property at that unknown temperature and also you know the value of triple point, then you can calculate the temperature, but that in Kelvin scale only. You cannot use this is for the Celsius scale. Triple point එක use කරලා ගන්න equation එක you can use it with Kelvin වලින් කරන් පස්සේ Celsius වලට convert කරගන්න පුළුවන්. You need to keep in mind then because that thermometric equation, the thermometer equations take a different thermometers of the use correct. Then we consider that for liquid glass thermometers, how we can use this. That's X means in the length of the mercury column or liquid column. X again thermometric property. So අපි Celsius scale එක ලියනවා නම් the liquid glass එකකට temperature you can write this is L theta minus L Celsius scale માં કેලිබර එනවා the lower fixed point එක විදිහට අපිට કેලිබර වෙන්නේ L0 එක. කියන්නේ 0 Celsius එක. The 100 Celsius minus 0 Celsius multiplied by 100. And then අර කලින් ලියපු equations මේ විදිහට එක එක thermometer the million Celsius thermometer scale වලට සහ එක එක thermometers වලට ඒකට ගැලපෙන thermometric property එක use කරලා ලියන්න පුළුවන්. අපිට කොටික for constant volume gas thermometer එක ලියුවොත් තමයි thermometer you can write this is Celsius million constant volume gas thermometer के आपके मायने pressure volume का constant pressure you change the speed theta the pressure at the theta Celsius the pressure at 0 Celsius and pressure at 100 Celsius and pressure at 0 Celsius and pressure also you can given by the liquid column the HRG as make HRG with HRG rho on the cancel. Then you can write with the height also. Practically every mine height difference. Maybe there may the resistance thermometer එකකට ගියාම මේක resistance එක මේක resistant ඕම් බලලා යන්න. හරි. ඒ වගේ මේ ඕන thermometer එකකට මේක use කරන්න මතක. හරි. Then by using this triple point also you can define මේ thermometer වලට ලියන හැටි කියලා මේක ලියන්න ගත්ත එකයි. ඒගාගේ equation එකක් triple point එක use කරලා මේ වගේම ලියන්න. So the temperature corresponding to the any unknown value electricity. If you know the value of the, I will use this instead of pressure, the thermometric property, the x at TR, and it is the x at the unknown temperature, right? X at T helium. So then you can write this using this gradients you can equal. This is equal 0. Then you can write then. Yeah, I'm writing there. Let's say this alpha, the tan alpha you can write as the gradient of this graph. That is x t minus 0 divided by t minus 0 equals to the x tr minus 0 divided by TCR, that's the triple point temperature, minus 0. Here the gradient of xt minus 0 is difference divided by this difference, and this small difference divided by the small difference. Right? So using this, you can write in the unknown temperature T, which equals to the xt divided by xtr multiplied by the triple point temperature. That's already you know the triple point temperature. Then if you know the thermometric property at the unknown temperature and thermometric property at the triple point, and multiply it by multiply it by 273.1, not 516, right? That's in Kelvin only. So this equation varied only for Kelvin scale, right? In the other temperature scales, you can't use this because the triple point is defined the linearly 0 and 10. Method Kelvin now the right. If not that Celsius method is 273. So take a 273.1. So this is in Kelvin scale. So this equation also you need to keep in mind, and also you should have an idea to get the temperatures with different thermometers they given with the different thermometric properties. Then you should have able to you write these equations. Let's say example. Let's say if you use the thermocouple, so these values becomes in linear region. These values, so this L becomes the electromotive force, and a resistance thermometer, this R, this L becomes R. Likewise, you can change it, right? According to the behavior of the thermometric property with the temperature, you can change. Eventually, it's not difficult one then. I will give you the example. If you use the lens, example is in a that's constant volume gas thermometer. If you use a triple point, then you need only 2 values. But in this equation you need to get a 3 values. And fixed point dekaka values to unknown එකයි තුනක් calculate the temperature හොයාගන්න. Then you need to use only 2 values. Triple point එකේ එකයි unknown එකයි විතරයි. Directly you can get. සමහර වෙලාවට දැන් පොඩි slight differences තියෙනවා ඒ කියන්නේ අපි දැන් ගන්නවා ගොඩක් තර්මෝමීටර් 4ක් 5ක් අරගෙන බැලුවොත් මේ එකම ටෙම්පරේචර් එකේ තියෙන ඒවා පෙන්වන values වල පොඩි වෙනසක් 0.1 ගුණ වෙනසක් වෙනවා. ඉතින් gas thermometers වලත් එහෙමයි. gas thermometer එක තමයි accurate ම කියලා ගන්න. ඒකේ පොඩි වෙනසක් තියෙනවා. The reason is use gas is not ideal. Ideal gas එක නෙමෙයි නම් use වෙන්නේ. ගොඩක් වෙලාවට අපි use කරන gas real gases. ඒක oxygen, nitrogen, helium. Normally ඒවා තමයි use කරන්නේ. ඒකට 0.1 0.2 වගේ difference එකක් තියෙනවා. That's the only thing. I'm going to have a question. What is the reason for the difference between those? You can write in humidity and ideality of it. Okay. I'll give you the question tonight. Yeah. Question related to these. So 2 or 3 questions to discuss. Then for the next one, it's got that the expansion. I'm sorry. So then I question two ideal gas thermometers. The right question. Two ideal gas thermometers. Capital A and capital B. Capital B use of capital B use oxygen and hydrogen respectively. Use oxygen and hydrogen respectively. Right. The following observations are made. Following observations are made using those thermometers. Hold on. This is the pressure of the thermometer 1. A. This is the pressure of thermometer B. Right? Pressure thermometer A pressure again, thermometer B pressures. The temperature is correct in simple point of order here. It's 4 triple point of water. This thermometer given the pressure is 1.250 into 10 to the 5 Pascals. This gives you that 0.2 into 5 Pascals. And this is gives that normal melting point. Point of is 1.797 into 10 to the 5 Pascal. And then 0.287 into 10 to the 5 Pascal. So thermometers given these values, right? That's the part here of the question is the absolute temperature of the sulfur, normal melting point of sulfur. Melting point of sulfur. That's Rate by the term A and B. Part B of that. What is the reason for slight different answers from A? Right? Different answers from A. So I'm here one temperature. For the calculations, you can use that triple point temperature 273 ಇರಗಂಡು 1.16 but in the same they ask you that the correct answer is not given. In here I'm given it TR is 273. right? Okay, now we can calculate, right? Here the temperature equals to the this x, and the temperature divided by the x to the triple point. Divided by the triple point temperature. Right? Use this equation for the thermometer A. Let it A the value, that is x3, that is at this value. That's 1.797 divided by 1.25 into the 5 cancel out, and temperature 273. That value you can get from this. Right? Gives you this 200, 300, 392.46 Kelvin. And for P, it's given as 0.287 divided by 0.2, 173. So that's 391.76. So approximately equal, but little difference there. So the reason is then because this oxygen and hydrogen values, right? So those are not the ideal gases. So slight difference in the temperature as required. Two thermometers are then due to the oxygen and hydrogen. This do not be ideal gases. Right? The answer like that. So slight difference is due to the fact that oxygen and hydrogen do not behave as ideal. All right. Okay. And final point about this temperature thermometer. We need to describe this thermometer thing one by one. What is that liquid thermometers, like mercury thermometer, and what is the properties of that, and resistance thermometer, and the thermocouple. Copy just one by one. It's not I will send you that, so you can go through it then again. I think if you have this thermometer wrongly calibrate correct, යගේ එකක් කොහොමද correct කරගන්න කියන එකක් තියෙනවා. quality thermometer එකක් correct කරන්න. Right. Give it as a question, then it is better. So you can write another question then. A faulty thermometer reads freezing point and boiling point. Freezing point and boiling point. Freezing point and boiling point of water as 5 Celsius and 95 Celsius respectively. What is the correct value of temperature the correct value of temperature. Acid rate 60 Celsius and 40,000. Quality given 60, actual value become complicated. In let's say this is the term. The 40 is the correct one. Quality again we make a calibrate 95. Here read but the correct value is 100. It's a freezing melting point, boiling point. Sorry. The freezing point is elevated. Should be 0 at the correct. Now this rate 60. They're asking what is the value of incorrect. So then it's this difference which corresponding to this difference in correct. They're the same length in the term it shows. And this difference similar to this difference. You get the ratio form. Ratio that is x minus theta minus not x 100 minus x not. Let's see. Firstly, this is the thermodynamic property which is inequality or in one you can it is same. Then you can use this as a temperature difference. Where is theta minus 0, that is I will write it as x of x point and theta of x point minus theta of x point. You can equal the 41 you can write this as this is 60 minus this is 5 and this is 95 minus 5. And for a because this value is same for both the cases. The correct one is 100 minus 0. So that's theta. We need to find here the theta minus 0 and divide by 100 minus 0 for 40. So then you can find this thing. Theta is equals to 55 by 590 multiplied by 100. Divided by 9. So it's 61.1. So this is the correct value. That is shows 60, but actual value is 61.1. The other way around also you can write it. The correct value, let's say the second part, let's is temperature at the correct temperature. Let's see it is 80 Celsius. For 80 Celsius, how much the value shown by this? I write it as part B. For correct 80 Celsius value. So in what is the temperature shown in this thermometer? So you can use that is theta dash minus 0.5 divided by 95 divided by 5. It's 80 minus 0 divided by 100 minus 0. That's the dash you can find. You multiply by 90 plus 1. in 72 by 70. So in this thermometer reads 77 Celsius. So it's corresponding to the actually 80 Celsius. Okay, that is the way you corrected the wrongly calibrated thermometers. The thermometer equation is important. Yeah, after this point. To give some response. So, yeah, go on to something further. Different thermometers. That's plastic given you. That's mercury glass thermometers. There are two reasonable basically that's a mercury glass thermometer and also alkaline glass thermometer. We can use that as a liquid glass thermometers. Constant pressure gas thermometers there, and it's also we can use in two different ways. Constant pressure gas thermometer, constant volume gas thermometer. We can use that to both the at constant volume gas thermometer, the same gas thermometer we can use. That's volume we keep constant and we measure the pressure. The other way, pressure we place constant and we will measure the volume. Volume keep constant pressure, we measure the pressure, or pressure keep constant and volume measure. Both the case we can consider. And then platinum resistant thermometer, we call it the resistant thermometer or it's thermistor, and the thermocouple thermometer. The others are pyometers and vapor thermometers. Now it's not in use, but that's our thermometers are also there. That's much different now. First, we consider the mercury in glass thermometer as a liquid. Mercury in glass thermometer. නිතරම දැකලා තියෙන thermometer so මේක uniform cross section එකක් තියෙන්නේ at the end of this bulb is there. මේක ඉතින් it's a thin wall of bulb. The temperature rapidly me get to the temperature gone down. So yeah, we get capillary tube. Uniform cross section at the section is uniform. At the beginning, cross section එක අඩු වෙන තරමට තමයි sensitivity එක වැඩි කරගන්න පුළුවන්. අපි මේක කියන්නේ class hall එකක් තියෙනවා. මේකද තියෙන එක කියන boy එකක් කියලා. mercury column එක. Bulb with thin wall, right? අපි කියන මේක තමයි scale එක හදලා තියෙනවා. scale එකක් තියෙනවා මේකේ. That's one step. Parts of this thermometer is right. Here this uniform cross section of capillary is there. So then we measure this thermometric property in this thermometric properties. That's X means that is a volume of the mercury. Volume of mercury. As cross section is uniform, you can say then X equals X proportional to length of the column. So then you can consider the length as the thermometric property as provided that the cross section is uniform, right? And the material is called as metal. And also can use alcohol. We call it alcohol thermometer. Usually its range of measuring. The mercury has the boiling point at 357. Then you can measure up to 350 Celsius. And its boiling point is about -38. So then we can specify the range is from about -30 Celsius to 350 Celsius. This quantum range is there. එම තිබ්බට දැන් මෙතන මේක උඩ එහෙම පොඩ්ඩක් ගිහිලා ඔහොම රවුමක් වෙන දාගෙන මෙතන උඩ තව ගෑස් ස්පේස් එක වැඩි කරලා ගෑස් එකක් විදිහට තිබ්බොත් එහෙම මේ ප්‍රෙෂර් එක තව වෙනස් වෙනවා. ඒක වොලියුම් එක තව ලෙන්ත් එක ඉන්ක්‍රීස් කරන්න පුළුවන්. කියන්නේ තමයි හීට් එකකට ගෑස් ප්‍රෙෂර් එක වැඩි කරාම බොයිලින් පොයින්ට් එකක් වැඩි කරන්න පුළුවන්. at 350 වල විතරක් නෙමෙයි අපිට පුළුවන් වුණා up to 500 වෙනකම් මේක එක්ස්ටෙන්ඩ් කරන්න පුළුවන්. මේවා තියෙනවා මේ ස්කූල් යුනිවර්සිටි ලැබොරටරිස් school laboratories online. Mainly you need to know about it because if you use a thermometer, mainly laboratories this should be measuring range range of measurement should be large. Sensitivity very big. There should be the quick response sensitivity again. Once Celsius degree, okay, in a thermometric property it's considerable window. And up to 1 Celsius or 1 centimeter with the pen is a better sensitivity. 1 Celsius or 1 millimeter with the pen, product sensitivity card with sensitive again. Celsius change 1 millimeter up in the ahead of it. Enough for it has low time sensitivity. The sensitivity very window. Good thermometer. Quick response එකකුත් තියෙනෝනේ. නැත්නම් thermometer එකේ තියලා වරුවක් බලන්න. අපි constant volume gas thermometer ගත්තොත් මේ quick response එක අනේ gases gas කියන්නේ heat හොඳට transfer කරන material එකක් නෙමෙයි. But it takes long time, but it's accurate. අනිත් එක finally we call that is the accuracy should be. දැන් අපිට expansion වලදී ඉගෙන ගන්න පුළුවන් මේ bulb එකේ volume එක වැඩි වෙන තරමට තමයි හොඳ sensitivity වැඩි ගන්න පුළුවන්. එහෙම කියලා bulb එකට ගොඩාක් එකක් දැම්මොත් mistake more heats from the substance you are going to measure. To be measured, right? Heating heats එක ගොඩක් අරගත්තොත් එහෙම heats වලට අනුව temperature එක කියන්නේ මේ heats එක කොහෙන් හරි absorb කරනවා නම් ඒකේ temperature එක අඩු වෙනවා. එතකොට mind යන එකේ mind temperature එක this not the actual temperature. ඒ temperature එකකින් heats එක අරන් තියෙන thermometer. මේක ගොඩක් අඩු කරන්න ඕන හින්දා bulb එක එහෙම ගොඩාක් ලොකු කරන්න බෑ. ඒක හරි. අනිත් එක තමයි sensitivity ගොඩක් වැඩි වෙනකොට තව ප්‍රශ්නයක් වෙනවා. sensitivity වැඩි කරන්න කියලා කියන capillary එක අඩු කරලා එහෙම කරන්නත් පුළුවන්. එතකොට වෙන්නේ thermometer එකත් ගොඩක් දිග වෙනවා. ඒක handling අමාරුයි. point එම වැත්තම් බලපන්. හරි. ඊට ඊට පස්සේ ඔක තින් වෝල් එකක් බල්බ් එකක තියෙන heat transfer එක quick responses වලට ඒක හොඳ වෙනවා. ඒ වගේ you can discuss about the advantages and disadvantages of this mercury gas thermometers. So if you consider about the advantages, actually the mercury gas thermometer is the cheapest one. It's a low cost. And also අනිත් thermometers වගේ නෙමෙයි, you can take the readings directly. Okay, means that there's a scale on the thermometer and then you can directly read it. So readout mechanism is easy. So then you can write that reading can be taken directly, and handling and transportation is easy. And also we know that the mercury is a good thermal conductor, and also it's a good heat transfer. So then heat can be transferred quickly from the surrounding through the mercury, and then give it a quick response. Response quickly. And mercury is opaque, so then the identification of the change in thermometer is easy. නැත්නම් ඔක transparent liquid එකක් වුණා නම් ඒකේ කොහෙද තැන කියලා හොයාගන්න එක difficult. And also mercury is not wet in the glass. දැන් ඒ වගේ liquid එකකට ගන්න ඕනේ properties උත් තියෙනවා. ඒකත් ඔය එකම හරිය කියන්න පුළුවන්. එකක් තමයි මේ liquid එක glass එක wet කරන්නේ නැති වෙන්නේ. Not wet in the glass. Yeah, wet glass එක wet කරොත් එහෙම liquid එක glass එක දිගේ ඇලිලා ඉන්නේ. So it's not a good practice, right? And also that liquid should not have the higher density. Make it then our mercury then the pain because mercury is high density එකක් තියෙනවා. but එක high density නැති වෙන්නේ. ගොඩක් ලොකු density එකක් තිබ්බොත් එහෙම weight එක වැඩි. ඒකට ඒක opaque වෙන්නේ. mercury නම් opaque තමයි. Transparency is difficult to read. So then specific heat capacity, yani කොච්චර heat එකක් කොහොමද temperature එක වැඩි කරන්න කියන එකත් low heat specific heat capacity එකක් තියෙන්න ඕනේ. High specific heat capacity එකක් තිබ්බොත් take more heat from the object to going to measure the temperature. So then it's a bad practice. So it's not a good thing, right? For expansivity කියන එක it should be linear, and also it the expansion එකක් තියෙනවා temperature එක පොඩ්ඩක් ආවත් the expand වෙනවා. So the better sensitivity. ඒ වගේ properties තමයි තියෙන්නේ. ඒ conductivity එක හොඳ වෙන්න ඕනේ conduct කරන්න. ඒ වගේ properties තියෙන්නේ. I will give this as a summary. There are also some disadvantages also there. So then capillary tube again the boy ke non-uniformity errors in the whole. There may be some errors due to the non-uniformity of capillary tube or the thermometer. Right. Also it takes some heat from the object to get pressure. The thermometer reads little bit lower reading than the actual value. So the temperature heat temperature hardware. So taking read reading whatever. So then other vapor pressure reading at any temperature above the liquid, they are having their own vapor. That's a vapor pressure is different in different temperatures. So then some errors happen. Pressure in දැන් පල්ප් එක තියෙන්නේ පල්ප් එක තමයි අපි ටෙම්පරේචර් රීඩ් කරන තැන කියන්නේ. මේ මුළු තර්මෝමීටර් එකම ඒ ටෙම්පරේචර් එකේ නැහැ. මේ තියෙන සරවුන්ඩින්. මෙහින් heat absorb වෙන විදිහට මේ තියෙන temperature is different from the temperature of the bulb. So that's also an error. Because that error happens due to the temperature difference between the bulb and the bow of the thermometer. Right? There are no high degree accuracy. So those are the disadvantages of this mercury thermometers. Right? about the mercury properties. And then as a comparison, I will send you the table of this all together, right? And then the syllabus I have discussed about this thermocouple thermometer. Thermocouple thermometer. If you consider this two dissimilar materials like copper and iron, and you can make a junction. Take two dissimilar materials and use and if you place these two junctions, you can make two junctions using two dissimilar materials. Let's say this is iron, this is copper, and these two junctions are there. If you place these two junctions with two different temperatures, let's see, when we place at the cold temperature, let's say ice we use, others place in a hot bath. Say this is as a thought, and this is ice already here, this stream. Then we can connect the milliwatt meter or milliammeter to measure the potential difference between, but according to the Seebeck effect, called as Seebeck effect. Yeah, temperature difference. Dissimilar junctions, temperature difference. Due to that temperature difference, that electromotive force is induced between these two junctions. This is called the cold junction, and this one cold junction, and this one hot junction. So then they are between these two. That's the potential difference. That potential difference we call as the electromotive force. Right here, the EMF we can consider this is the electromotive force. Up to now, you can discuss with electromotive force later. You need to know that electromotive force is similar to the voltage difference, right? Potential difference. That's not bigger value; it's small value difference there. Body temperature වෙනස් වෙනවා millivolts microvolts විතර difference එකක් තමයි තියෙන්නේ. ඒකට එක ගොඩක් දෙන materials තමයි copper iron junction එකක් තමයි. Copper iron, copper nickel nickel, platinum and platinum rhodium alloys, copper and constant වගේ materials. That's the platinum වගේ use කරන්නේ මොකද ඒක expensive but accurate. Right. So මෙතන දැන් සාමාන්‍යයෙන් ඔය potential difference එක තියෙන temperature difference එක තියෙනවා නම් ඒකට අනුව මෙයා electromotive force එකකින් call it electromotive force. Still I use for the electromotive force. Electromotive force. So make indicate temperature, let's say the sets constant with theta1 and this with theta2. So make අපි සාමාන්‍ය calibration එකේදී මේ practical කරද්දී මේක කමක් zero වල තියා ගන්නවා. Zero sets. අනිත් එක තමයි temperature එක mind පාවිච්චි කරන්නේ. So මේ junction එකත් ඔය හරි place එක තිබ්බාම ඒ difference එකට corresponding electromotive force එක මේක induce කරනවා. That electromotive force is proportional to that temperature. So මේකේ න curve එක graph එක is not linear at all. The linear region එකක් තියෙනවා මෙහෙම. ඊට මේ වගේ curve එක. 100 Celsius විතර වගේ වෙනකම් මේකදී this is just theta. This is electromotive force in milliwatts. So මේකේ අර වගේ එක එකට එක උත්තරස් නෑනවා. thermometric equation you can use. In this linear region, you can use the thermometric equation as epsilon at theta Celsius and epsilon at 0 Celsius minus epsilon at 100 Celsius minus epsilon at 0 multiply by 100 Celsius. But it's not the linear. So all the range you can use this. When you use it in all range, that equation you can use. That equation gives you the electromotive force corresponding to the theta temperature. That's equals to the E plus B theta plus C theta square. So ABC are constants here. Constant. So that's why this given the curve. So you can calibrate this also. You can make curve because if you make a problem, linear range and make a power. It's for a linear range only, right? Linear range on. But for other region, you can use this equation. How you can measure the temperature using this? First, you need to calibrate. Right. Calibration means you need to find the value of this ABC constant. You can do it by placing the prop, this chip of this thermometer. Make a multimeter එකකට වගේ connect කරන්න. මෙතන chip එකක් නිකන් පොඩි තුඩක් තියෙන පෑන් තුඩ වගේ මේ junction එකේ තුඩ ඕන තැනක you can place you can measure the temperature then. ඒක තියලා එක different temperatures තුනක අපි non temperatures කෙමු එකක් දැන් 0 Celsius. ඒක මම ගන්න 10 and 20 කියලා. තුනක් අපිට temperature produce කරන්න. If 0 වල තිබ්බ මේක theta 0 0 දැම්මම this E0 let's say it's equals to 8. And then you can make another equation at E10 is at 10 Celsius. The method 10 10 A plus 10B plus 100C. The equation A you already know. 20 වල තිබ්බොත් ඔය වගේ 20 කියලා දැම්මම මේක values එක මැන ගන්න පුළුවන්. So this is A plus 20B plus 400C value. Equation if you know this ABC value, you can find it. There are 3 unknowns and 3 different equations. If again unknown temperature values are ABC, you can calculate. Temperature thermometer constant. A constant to equation again. Made in a I can find the theta value. Corresponding theta values you can find. Look at digitally in a temperature junction. That's a semiconductor. A semiconductor is 0 Celsius in Vidya. This is then junction junction temperature you can measure. From making a bit mass measuring range. I make it in main features measuring range it's a minus 200 Celsius 1400 Celsius measure again accurate make it response that is quick response response accuracy in something like more accurate. It's more accurate. Make it in a positive pick up. pen තුඩක් වගේ. ඒකේ thermal capacity of that junction is so small. When we used to measure the varying temperatures. Measure can rapidly changing temperatures measure කරන්න it's good. ඒ වගේම surf දැන් අපි glass thermometer එකක bulb එක ටිකක් ලොකු ඉඳලා surface එකක වගේ temperature mine එකේ ඒකෙන් difficult. ඒ bulb එකේ එක චූටි area එකක් විතරයි මේ surface එකේ touch වෙන්නේ. නමුත් මෙතන ටිප් එකක් වගේ එකක් use කරද්දී මේක මේ කෙලින්ම දැන් මෙහෙම chip එක තියලා wire එකක් එක්කම පොඩි tape එකක් ගැහුවාගේ මේ surface එකට තියෙනවා. එතකොට මේ surface area temperatures measure කරන්න it's very good. A small with a water drop temperature then අපිට thermo liquid class thermometer එකකින් drop එක වගේ temperature mine එක difficult. But in this thermometer you can use to measure the temperature of a small object or smaller bodies like the water drop. And then millivolt meter එකක් එක්ක calibrate කරලා ගත්තාම read out mechanism එක මේකට කලම් එකට වඩා ලේසි. ඒ මේකේ කියනවා value එක පෙන්නනවා මේක දශමිකම මෙච්චරයි. නමුත් අපි මේකට කලම් එක ගත්තොත් මේ හැදියලා බලාගෙන යන්න බෑ. මේකේ වෙන කෙලිම place the any place you can get the temperature there. But then maybe the disadvantages that make it calibrate kind of potentiometer. But potentiometer accurately measure can't use can get them difficult make it and potentiometers come not electricity or internal resistance internal resistance in the effect take a potentiometer now digital equipment එකක් විදිහට අපි multimeter එකක් use කරද්දී internal resistance එක මේකට effect වෙනවා ඒක අනිත් එක මම කලින් කිව්වේ දැන් junction එකක් cold තියන්න ඕනේ අනිත් junction එක hot තියන්න. ඒ cold junction එක හැමතිස්සෙම 0 විදිහට consider කරන්නේ. ඒකට ඒ දෙකේ මොකද අපිට උතන temperature difference එක තමයි එමන්නේ. එකක් තියාගත්තොත් තමයි හරියටම temperature එක කියලා කියන්න පුළුවන්. දැන් difference එක ගන්න ඒක 0 වල මේන්ටේන් කරන එක ටිකක් ඩිෆිකල්ට්. ඒකට semiconductor එකක් අපි යූස් කරනවා. So the disadvantage එක තමයි මම අර කලින් කියන graph එක. This graph is not linear graph, so it is non-linearity. So then the linear calibration you can use. We cannot use that's above 400 Celsius. Up to 400 only you can use the linear relationship. But that linear relationship you cannot use for high temperatures. So that's another difficulty, another disadvantage in this thermometer. Right. In this thermometer also someone given the two values corresponding to the two different temperatures with the EMF values they given. Using the equation you can calculate. Again, I will give you that comparison as a table. And then another thermometer, that's resistance thermometer, you can use the resistance values too. Resistance thermometer, you can put platinum resistance here. The poly resistor එකක් තියෙනවා ඊට පස්සේ මේක වෙනවා. මේක මේකේ මේ මේක තමයි ඒ ක්ෂණීය විදිහට පාවිච්චි කරන්න කියන්නේ. ඒතන තමයි sensitive part එක විදිහට පාවිච්චි කරන්නේ. කියන්නේ මේක වෙනම කනෙක්ට් කරලා තියෙනවා මේ instrument bit circuit එක කරේ ඒතර මෙතන small change එක මේ පැත්තේ අපිට change එකක් විදිහට කියන්නේ. ඒකෙන් ගන්න පුළුවන් විදිහට මයින්ඩ්. දැන් මේ වගේ හදපු yang paling kali kali temperature kamu nasinya resistance given nasinya pindah ya tapi kan thermistors thermistors. The thermistor එක දෙපැත්තක් තියෙනවා. සමහර ඒවා තියෙනවා temperature එකත් එක්ක resistance එක අඩු වෙනවා. ඒ කියන්නේ අපි semiconductors use කරොත් semiconductors වල resistance එක norm we measure system එක semiconductors වල මේක තමයි අඩු වෙන එකක් තියෙනවා. ඊගොත් conductors වල එක වැඩි resistance එක වැඩි. conductors වල වැඩි. කොට අපිට දෙපැත්තම පාවිච්චි කරන්න පුළුවන් කියන්නේ. මේ වගේ ඒවට අපි කියන්නේ NTC කියලා negative temperature coefficient කියන ඒවා. මේ ඒවට අපි කියන්නේ BTC කියලා. positive temperature coefficient කියන්නේ. මේ resistance එකත් එක්ක තියෙන temperature එක relation එකක් විදිහට. electricity එක කතා කරන temperature theta resistance at theta temperature that's equals to the resistance at 0 which is 1 plus මේක මේ linear range එකට විතරයි. මේ linear නැති non-linear range එකකදී අර වගේ theta square එකකුත් වෙනවා. range එක විතරක් අතෝ thermometer එකක් විදිහට use කරන්නේ මේක. Alpha is called the temperature coefficient of resistance. ආන්ගේ coefficient එක තමයි මේකෙදි මේ NTC මේ විදිහට use කරන්නේ වෙයි alpha is negative. මේ වගේ වැඩි වෙන ඉමේජ් resistance එකත් එක්ක that alpha is positive. දෙපැත්තම thermometers වලට use කරන්න පුළුවන්. දැන් දැන් මෙතන temperature corresponding you can get the resistance value. මේකේ resistance value එක අපිට පුළුවන් ඕන අඩු පැත්තට වැඩි කරන්න. you can use ගොඩක් කරාට මේ thermometer එක use කරන්නේ resistance thermometers වලදී use කරන්නේ වැඩිපුරම platinum. The platinum is expensive. ඒක තමයි main නිසා. So the measuring range එක ගත්තාම සාමාන්‍යයෙන් අපිට පුළුවන් 1000 over not measure කරන්න. resistance හරි. ඒකේනම් මෙන්න disadvantage එක මේකේ තර වගේ පොඩි tip එකක් තියෙන්නේ. accuracy එක ටිකක් අඩුයි. හරි. එකක් මේ non-linearity එකේ ඉඳ accuracy එක අඩු වෙනවා. linear නැති. මේ ටික compare කරලා I will give you the table. You keep in mind the answer short of the CC. Thermometers can it's all together thermometers with this all. So next we need to discuss about the expansion of solid. I will send you the expansion of solid notes before the next class. Then you can come to it right ready. All the expansion thing I will do as a note, right? So and also this previous notes also I will send you, and you go through it. Any questions you have, you can ask. Right? Then meet next week. I will start the class from this point today. For your participation. If you have any question, you can ask. I'm trying to comment. ඒක ආලගේ ස්කෝප් එක ගන්න කිසිම ගන්න ඕනේ නේද දන්නේ නැහැ. Okay, thank you. We'll next week. God bless for